Hello everyone, this is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So in this video, we will see twisting and wrapping of shear loaded closed section beam. So for closed section beam, how twist and wrapping will be there, that we will see in this video. Okay, so our lecture topic will be twist and wrapping of shear loaded closed section beam, the first topic, and in this video, we will see also the displacement associated with the breadth batho shear flow. So these two topics will cover in this video. Okay, so let's start with the first topic, that is twist and wrapping of shear loaded closed section beam. So twist and wrapping, these two are there. So just see, shear load which are not applied through the shear center of a closed section beam causes cross section to twist. That already in previous video also we have seen. If we don't want torsion, then we have to apply the load at the shear center. If that other than the shear center, if you will apply the load, then twist will be there. So that's why it's given here. In the closed section beam causes cross section to twist and wrap. That will get twisted and wrapped. That is, in addition to rotation, they suffer out of plane axial displacement. So just see, this word is important. Out of plane. Why? Suppose this one is there and in any plane is there. Once we will twist this one, then definitely whatever like this is there. After twisting, what happened? This is just changing like this. Right? So this is changing. This they will go out of the plane. Right, so that's why it's here, suffer out of the plane axial displacement. So along the axis, displacement will be there. Okay, so expression for these quantities may be derived in terms of shear flow distribution. So how that will be there, or how we can find? How? By shear flow distribution, that QS, as follows. How? So see, since Q equals to tau T and tau equals to G gamma, this is for strain, right? Then we can express QS in terms of the wrapping and tangential displacement. So now then we can represent, or we can express QS as wrapping and tangential displacement W and VT. So wrapping is W and tangential displacement is gamma T. That's okay, of a point in the beam wall by using the equation. So this type of already we had seen there, this del W by del S for the closed one, right? Plus P d theta by dz, and then this was dw by dz cos psi and dv by dz sin psi. That was it. Already that we had seen from here, but that angle is not there and it's closed one. So closed one is this term will be there. Okay, and only one displacement is here. What? That is Vt. So that's why here Vt is there. Okay, now substituting for del Vt by del z, we have. So what is that? The C. This GT, just take this side. So Q by GT. For this one, that is del W by del S. And for VT, the C. Now that we are putting finally, again, we reach to the that equation, that shear stress distribution equation. What is that here? VT, the displacement. That is P d theta by dz plus du by dz cos psi plus dv by dz sin psi. So after combining these two, now it becomes for the closed one. If that is for open section that we had seen, only this part will be there. Okay, so now we are discussing on the what? Closed beam. So that's why this part, this term also del W, that wrapping will be there, del W by del S. Okay, so now just see, this equation is the integrate the above equation, that is this equation. So what happened after putting here integration sign, here integration, P will be constant, so here integration, right? Here integration, integrated just. So after integration, just see here, above equation with respect to S. Okay, from the chosen origin, whatever the chosen origin is there, like the previous question, we have selected 1 as the origin. So from 1, and noting that G may also be a function of S. So here G is also not constant. So we cannot keep this out of integration. G can also be a function of S. Okay, so after putting from where to where, for that entire S we are integrating, so this from 0 to S. So Q by GT into ds, that one, that is equals to 0 to S, del W by del S into ds plus d theta by dz is constant, 0 to S p ds, okay, plus du by dz, again this is constant, so out of the integration 0 to S cos psi ds plus dv by dz, again that is constant. So 0 to s integral of sine psi ds, right? So this is just after integrating. Now further simplifying this one. So 0 to s qs by gt into ds, that is equals to, this term will be same, 0 to s del w by del s into ds plus, again from this term d theta by dz, 0 to s p ds, okay, plus du by dz constant, now cos psi ds. Okay, if you remember that formula in that previous figure where we used that angle was there like some this one, and here this angle was psi, right? So from that figure only the cos psi will be equals to what? That dx by ds. So if you will cross multiply, what you will get? Cos psi ds equals to dx. So for cos psi ds, can we write dx? So that only is cos psi ds is dx. Similarly for sin psi ds is dy. Right. So in this term only we replace this to dx and this term to dy. Remaining all everything's are same. Okay. Now we don't have psi, right? Cos psi and sin psi means now we have to just integrate this one. So after integrating, what we will get? After integrating and substituting the limit. So this part just we are keeping. Okay. 0 to s qs by gt into ds. Now this one, ds cancel, integration of del w will give you what? W, right? So w, okay, limit from where to where? 0 to s, plus for this one, that p ds, that already we had seen that is 2a, right? So here just for also 2aos, just for denoting 2aos, and this theta is common. So here, right? So here w is not there, means 2aos, or 0 to s you can say simply area 0 to s, not os, 0 to s. Okay. Plus similarly for dx, integration will be so into d theta by dz plus this du by dz, okay, and integration of dx is x. So from where to where? X, 0 to s, plus similarly this is dv by dz remains there, and into integration of y is, sorry, dy is y 0 to s, right? So after putting the limit here, what we will get? ws minus w0, okay, from this part, plus this 2ao to s, that is 0 to s, into d theta by dz for this term. Now next this plus du by dz into what? xs minus x0, and plus dv by dz into ys minus y0. So this will be equation. So just see, this is the equation, right? Just I showed you, after substituting the equation we got this equation. So next let's see, where a, this is 0 to s, a o 0s is the area swept out by a generator, center at the origin of the axis. So center is at the origin of the axis. O, from the origin for s to any point s, from origin to s, there any point s to which is surround to the cross section, that s around the cross section, continuing the integration, right? After that completely around the cross section is from above equation. So from above equation, this, right, after the CR is equals to 2a d theta by dz. So this term will be there, remaining all these are constant, so that term will get vanished and that becomes 0. So hence that's why it's there, origin O. So just origin O means what? It's not 0 to s, is that also 0. So what, wherever the 0 is there, just put s as also 0. So after putting here s as 0, w0 minus w0 cancel, x0 minus x0 cancel, y0 minus y0 cancel. So hence all terms get cancelled, only this term is left. So hence close integral of qs by gt into ds equals to 2a d theta by dz. So this is one important. Now From here, we are finding d theta by dz. So d theta by dz is what? Just take this 1 by 2a this side. So 1 by 2a closed integral of qs by gt into ds. Okay. So this is for d theta by dz. Now we have d theta by dz. Okay. Now substitute back. So, okay. So that is the finally displaced. That is called twist, angle of twist. D theta by dz is equals to 1 by 2a closed integral of qs by gt into ds. For this full derivation, we will see in futures video. Okay, now come to the next topic, that is displacement associated with the bathysphere flow. That is our second topic of this video. So in this topic, what is that? The relationship between Q and shear strain gamma. So now we will see Q and shear strain gamma is valid for the pure torsion case, that already we had seen. Only we are applying the torsion, right? Where Q is the constant. So in pure torsion, that time Q is constant. What is Q? Q equals to GT, okay, del Wy. So from here we will start in all the cases where the shear distribution will be there, shear stress distribution. In previous concept also we started with this one, and later we substituted del Vt by del Z value, right? So from again we will start by this equation only now, but there we substituted the value of del Vt by del Z, but here we will not substitute. Here what we will do, because del Q by del Z, we found that one, right? So in the same way we will differentiate this equation. So let's differentiate this equation. Okay, so after differentiating with respect to Z, what we will get? Del Q by del Z, gt constant, so out of integration, differentiation of del W by del S is del 2W by del Z into del S. Why? Because with respect to Z we are differentiating, not with respect to X. So that's why this won't get S square. Okay, but here del Z is there. So differentiating with respect to del Z means del Z becomes del Z square. So del 2 Vt by del Z square, and for the equilibrium this must be equals to what? 0. Okay, so now we can see this term is equals to 0. So here del by, or simply we are writing this one, or just differentiation this one. So del by del S of del W by del Z plus del 2 Vt by del Z square equals to 0. Why? After taking this side, right, this term becomes 0. So now this term we have. Okay, so in the absence of direct stress, the longitudinal strain del W by del Z, that is that epsilon Z is 0. So now del W by del Z, this is 0, right? So del by del S of 0, that also will be 0, means this term will be equals to 0, right? Okay, so after this, when this is 0, then del 2 Vt by del Z square as 0. Okay, now we know that the tangential displacement Vt at any point, okay, and in the just any point n, it's not that fixed point is n, and you can take any arbitrary point on that one, you can take instead of that m also, in the wall of either an open or closed section of the beam. So this formula is applicable for both, either it's a closed or open section beam, because we are finding the tangential displacement, not the vertical displacement. So tangential displacement, either this is open, okay, or this is closed. Here we have to find, so that doesn't affect how that is closed or open section. So this we can use. So what is the general formula? Vt equals to P theta plus U cos psi plus V sin phi. Okay, now just, okay, this one. So differentiate. What we will get? Because the CR, this we know that del 2 Vt by del Z square is equals to 0. So what we will do here? First integrate this one. So after integrating, what we will get? Del Vt by del Z equals to P del theta by del Z plus del U by del Z cos psi plus del V by del Z sin psi. So first integration. Integrate again. Why? Because then we can put double integration for this value is equals to 0. So after integrating, once again what we will get? So integrating again. So that what we will get? Del 2 Vt by del Z square equals to P into del 2 theta by del or d2 theta, you can take d2 theta by dz square plus del 2u by dz square cos psi plus del 2u by del z dz square, or d, everywhere you can take d, right, dz square sin psi, right. So this term from here, just see, this is 0, so can we write this for 0? So 0 equal to this whole term, or you can say, yeah, just see, here it is. So this whole term is here, this is equals to 0, okay. This equation holds for all points around the section wall. So that's, we assume that any arbitrary point. That arbitrary point can be anywhere. So that's why this is valid for all the points around the section wall. In other words, for all the value of psi. So whatever the value of psi will be there, this equation is valid for all the value of psi. That already we had seen in the numericals. Like in one question that was psi, right? So psi is giving us 30 degrees, so we use 30 degrees. But in another question that is just arbitrary, that phi was given. So we assume that as phi. So it's not necessary that 30 degree is 30 degree only. We can use for any angle. And in second question also we can see that this question was there, like here this was arbitrary. So here we have taken from 0 to pi. So this is valid for all the values of that any angle, okay, or that is we are measuring in terms of psi. So that is valid for all the value of psi. Okay. Now if del 2 theta by del z square will be 0, d2u by dz square 0, and del 2v by del z square 0, that gives, it follows that theta equals to az plus b. Okay, just a different solution of this differential equation. Solution of this differential equation and solution of this differential equation. So for this, theta equals to az plus b. For this differential equation solution, u equals to cz plus d. For this v, so v equals to ez plus f. Okay, where a, b is the what? Constant, that is unknown. Okay, that is for theta. CD is another unknown constant for u, and ez, e and f is another constant for v, and that also is unknown. So what a, b, c, d and e, f all are unknown constant. Okay, so from here what we can say, theta equals to az plus b, sorry, az plus b. And just compare with this one, y equals to mx plus c, right? So here z is varying, here x is varying. A is constant, m is constant, b is constant, c is constant. So this follows like what? Linear equation, or you can say straight line equation, linear equation. This is equation of what? A straight line, right? So same here, in between theta and z, how this will be varying? The relation will be linear. So in theta and z, the function will be of linear type. Okay, so that's why here it is given. Theta, u and v all are linear function of z. So theta is linear function of z. Here u is linear function of z. V is linear function of z. So theta, u and v all are linear function of z. Okay. Now rate of twist. Earlier also we had seen this one. Now by Brett-Bateau. Okay. So rate of twist to the variable shear flow Qs developed in a shear loaded closed section beam is also valid for the case Qs equals to Q equals to constant. That already we had seen what, in that case Q is constant, right? So Q is constant, that is equals to Qs, hence Qs also will be constant. So what will be that? D theta by dz, already we found this Q by 2a, right? Q ds by gt, 1 by 2a into Q ds by gt, that's here. Yeah, Q s, in this case Q was not constant, so that's why inside the integration. But now what we are assuming, Qs equals to Q equals to constant. So now constant we can take out. So Q by 2a ds by gt. So in Brett-Bateau that we can do. Why? Because here we are assuming that dqs is constant, and that is equals to Q. So after taking Q by 2a, closed integral ds by gt. Okay, which becomes on substituting for Q. Now for the Q value, that again derivation is there, but here not. So just simply remember Q is T by 2a. Okay, just substitute here, instead of Q, T by 2a. So after substituting, what happened? d theta by dz will be equals to t by 4a square closed integral of ds by gt. So this will be what? The rate of twist, d theta by dz. In previous equation, what was d theta by dz? So see here, in twist and wrapping case, d theta by dz is 1 by 2a closed integral of qs by gt into ds, because here qs is not constant. But in case of dead batho, qs is equals to q and that is constant. Hence, that constant can be out of the integration and that q is t by 2a. So after substituting q t by 2a, we got d theta by dz equals to t by 4a square closed integral of ds by gt. Clear? So, okay, let's me recall once again both. Okay, so first concept we are seeing what? Twisting and wrapping of shear loaded in closed section beam. So from where we will start? Again with the shear stress distribution formula. So shear stress distribution is what? Us equals to gt into del w by del s plus del vt by del z. Remember here it's a closed beam. That's why this del w by del s term is there. Now substitute the value of del vt by del z. Why? Already we had seen here and that also. Right. This is the formula. If you will differentiate del vt by del z, you will get this one. Right. So for this value, substituting, what we will get here? Q dq by ds, differentiating this equation. Right. Okay. And then substituting for this one. So qs will be here and take this gt this side. So qs by gt, del w by del s will be there and del vt by del z is this whole thing. That is p d theta by dz into du by dz cos psi plus du by dz into sin psi. So we have to start that means you have to start from this equation. Okay. For if it's a closed ring, then this term will be closed. Then this one is there. This term also will be there. If it's a open, then only this term is there. Then later substitute the del vt by del z value. So after substituting del vz by del value, this whole thing becomes this one. But if it's an open one, then this won't be there. This term only will not be there. Remaining all will be there. That already we had seen. Okay. Now integrating the above equation. So after integrating, just put integral sign with each term. So integral sign of q s by gt into ds. So here remember we are not taking that q as common. Okay, is the okay, then that is equals to 0 to s del w by del s into ds plus d theta by dz into y, because this d theta by dz is constant, du by dz is constant, dv by dz is constant. So that will come out of the integration. Then only the variable thing. So for first case, in this case, what will be there? PDS will left. In this case, cos psi ds, and in this case, sin psi ds. For now, this PDS and boom area, just that we consider as 2A O to S. That is 2A. Okay. And for this one, after taking common cos psi ds in that angle of twist formula, earlier also I showed you that cos psi will be equals to what? Dx by ds. So just cross multiply, then cos psi ds will give you dx. So from here it's replaced to dx. Similarly for sin psi, that sin psi ds will be dy. So just substitute here, right? Remaining these two terms will be, that is up to this. It's same, just to remove the cos psi and sin psi, we used these two. Now just integrate. Right. So after integration, what we will get? Qs by gt into ds, that is equals to, so integration of this will be w. So w after putting limit 0 to s, that is ws minus w naught, because upper limit minus lower limit we are doing. So ws minus w naught plus d theta by dz is constant, and this whole area is 2a over that o to s, that 2 into area of that one, plus for this du by dz constant, integration of dx is x. So after substituting the limit, upper minus lower x s minus x naught plus dv by dz is constant. So again integration of d, that is dy, is y. So dv by dz into ys minus y naught after putting the upper limit and lower limit. So this is our integrating after this. Okay. So now let's see where AOS is the area swept out by a generator, right? And center at the origin of axis O from the origin. So origin where will be there, there is no twist, means what, this term at origin Ws will be equals to W naught, right? So W naught cancel. At again origin XS will be what, again at the origin if anything starts from there, so XS also becomes equals to X naught, and YS also becomes Y naught. So Y naught cancel, X naught cancel, W naught cancel. So which term is left? Only this term, right? So 0 to S, QS by GT into DS is equals to 2A to S d theta by dz. That is here. QS at origin only. This is at the origin. Okay, that's why WS, that whatever the S is there, that we substituted as 0. So from here just take, because we are finding d theta by dz, that is rate of twist. So take this 2A this side. So d theta by dz, that is rate of twist, is equals to 1 by 2A closed integral of QS by GT into ds. So this is our final equation, okay, for the rate of twist. That's why here it's twist. Okay. Now next is similar concept, that is displacement associated with the breadth-Bateau shear flow. Now breadth-Bateau, or you can say generally we are saying that breadth-Bateau formula also. So in exam that also that can be asked, like write or derive the breadth-Bateau formula. It's not necessary that they will give the whole thing. Means that is displacement, if that associated, it's a breadth-Bateau. Or if suppose displacement associated with the shear flow they are asking, then meaning also is same, that means you have to derive the breadth-Bateau formula. Okay, so don't confuse with the name, just see what is actually we have to find. If suppose they mention breadth-Bateau, then it's easier, you can directly go with this one. If not, if they just simply mention displacement associated to the shear flow, derive the equation for the displacement associated with the shear flow, then also you have to derive the breadth-Bateau formula only. Okay, so now just see what is the breadth-Bateau, the relationship between Q and gamma. So again we will start from here, that shear distribution formula, GT into del W by del S into del VT by del Z. Why? Because it's a closed section, so this term will be there. So now in this case the difference is there we substituted the value of this one, right? So this time instead of substituting the value of del VT by del Z, we will differentiate, right? So differentiate this equation. So after differentiating, what we got, del Q by del Z, that is GT is constant, so that remains constant, del W by del Z into del S. So just see, this won't get, because with respect to del Z we are differentiating, plus this one del 2 VT by del Z square, that is equals to 0. Now what we are writing, del by del S, del W by del Z plus del 2 VT by del Z square. Okay, so now after that what is there, just see here, in the absence of direct stress, there is no direct stress, means del W by del Z, that is the longitudinal strain will be 0. So put del W by del Z equals to 0 in this equation, so this term will be 0, means what you will get, del 2 VT by del Z square. That is here. We know Vt equals to, now start from this main form, right? Vt equals to P theta plus U cos psi plus V sin phi. Differentiate this one. After differentiating, again differentiate, means differentiate this equation 2 times. So after, I already showed you differentiation. So after differentiating 2 times, you got this one, right? That Vt. And just see, this will be what, del 2 Vt by del Z square. And what is del 2 Vt by del Z square? That is equals to 0. So that is here, that is equals to 0. Okay, this hold good for what, all the points on that one. From here what we can conclude, that del 2 theta by del Z square also can be 0, del 2 U by del Z square also can be 0, or del 2 V by del Z square, that also will be 0. So here, right? So now we have 3 equations. So for solving these 3, that is the differential equation. Solution of this differential equation is del theta equals to Az plus B. For this one, it's a U equals to Cz plus D, and for this it's a V equals to Ez plus F, where A, B is the unknown and constant for theta, C and D after integration, that what we are getting that as constant. So means A, B, C, D, E, F are constant, and that is unknown, means that you have to find. Okay, so thus theta, U and V are linear. So in this equation already I showed you how. So these are linearly related, theta and Z linearly related, right? Now let's find for the rate of twist. So rate of twist to the variable shear flow QS developed in a shear loaded closed section is also valid for the case QS equals to Q. So rate of twist is where that also is applicable or valid for when Q is constant. That Qs is constant. That is equals to Q. We assume. So Qs is constant. We assume that as equals to Q. Hence Q, that just replace Q S to Q. So after here, okay, in this equation, where is that one? Okay, so now d theta. So here that from here. Okay, so after substituting d theta by dz is q by 2, or from the previous equation that we got rate of twist d theta by that. What was the previous equation? From the previous one we got that d theta by dz equals to 1 by 2a close integral of qs ds by gt, right? Now qs equals to q and that is constant, so we can take out of the integration. So q by 2a close integral of ds by gt, that is d theta. Okay, so that is here, right? Now q is equals to 2a. Substitute here that q equals to, sorry, t by 2a. So after substituting, what we will get? D theta by dz equals to t by 4a square closed integral of ds by gt. Okay, so this is the this one, rate of twist by Brett-Matho formula, and that one was for the, because of the shear, this that wrapping. Okay, so this is the reference. Again, you can refer Maxon book. So you can see mostly, because that is your textbook, so mostly I'm referring to that, and I'm asking to refer the TSG Maxon book only, and you can go for the 4th edition, right? And there you will get these derivations. So if you have any doubt, you just comment on the video or you can ask personally. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.